We are going to see the calculation for the experiment sonometer. That is, you have to determine the frequency of the AC mains, that is the AC source, okay, using the sonometer. Okay, so what we are going to do is, we have the electromagnet connected to the AC source. Okay, so there is an alternating source, you have connected the electromagnet, and the effect of the electromagnet is going to be seen on the sonometer wire as it reaches the resonating length. Okay, it is going to vibrate vigorously. So using that, we are going to calculate what is the frequency of the AC source that is applied to the electromagnet. So this is the idea. So what we are first going to do is, we have all studied in our 11th standard, the frequency of the stretched string, vibrating string, is 1 by 2L root of T by M, isn't it? Where M is the mass per unit length of the wire. So here what we are going to do, we will split this equation as 1 by 2, 1 by root M and root T by L, because 1 by 2 is a constant and M is the mass per unit length of the wire, of the sonometer wire that we are using. So that is also going to be a constant, and the tension is what is the load that you are going to apply. So this is going to be a variable, and the resonating length depends upon the tension that you are applying. So root T by L is the one which you are going to calculate in the table. Okay, so what you will do is, you will write the formula as 1 by 2 into 1 by root M into root T by L, where M is the mass per unit length of the sonometer wire, and here the frequency of the sonometer wire will be written in what unit? That will be hertz. Okay, so then the resonating length is in centimeter and the tension in the wire is measured in Newton. So this you can write kilogram per meter. Okay, and then finally in the table or column, what you have to do is, you have to first write the serial number. Probably 4 to 5 readings you will be taking. Okay, so I will show you the demo calculation for the 3 readings. So first a serial number, and then the load that you are uploading. So usually you will have a 500 gram weight. Okay, so every disc will be equivalent to 500 gram. So 500 gram in kilogram will be 0.5. So if you add 2 of the discs, so you will get 1 kilogram mass, and then 3 of the discs you will get 1.5. So first, when you have the disc uploaded, only one disc is there, that is the mass will be 0.5, and then you will multiply that with a g value, that is acceleration due to gravity. Either you can use 9.8 or you can use 10 for easier calculation, your wish. Okay, so here we will multiply with 9.8, so you're getting 4.9. Here we will multiply with 9.8, so you're getting 9.8, and then 14.7. And then in the third table, you will calculate the root of this value, okay, root of T. And here you will write the unit as root of N, root of Newton. Okay, so don't forget to write the units here inside the table also. So root of N, when you calculate, you're getting 2.2, 3.1 and 3.8. So far the readings are same. Now change is there. And then finally what you're going to do is, you're going to calculate the resonating length by adjusting the knife edges. Okay, so you will adjust the knife edges, and then at a particular value you will be getting the resonating length. Okay, so for the load 0.5, okay, the reading is, just I'm going to give you sample reading so that I will show you how to do the calculation. Okay, so for the load 0.5, we are getting 30.5, and then here it will be 29.5. Okay, that is the return, that is, sorry, this is loading and this is unloading the wire. So once you are loading, so first you have added 0.5, you will measure 30.5, and then you will add 1 kilogram of mass, and then you will get 43.5, and then when you add 1.5, for example, you are getting 54.0. So then you have to unload it. Okay, so while unloading, the third reading will remain the same, that is the last reading will remain the same, and then you have to move upwards. So that is, you have to move one load after the other, and then you will do the experiment again. So when you do the experiment again, so let us say you're getting 43.5 once again, and then here you're getting 29.5. So you have done 2 trials, one is loading and the other one is unloading, and then you have to take the average. Okay, so the mistake that you do while using the calculator is, while taking average, what you'll do, 30.5 plus, when you're typing in the calculator, plus 29.5 divided by 2. Okay, you will do like this. So if you do like this, what will happen is, only this part will be divided by 2, and then this will be the division of that, the answer of that will be added with 30.5, which is wrong. You have to first add and then you have to divide, isn't it? So you will use a bracket. So you open a bracket, 30.5 plus 29.5, close the bracket, and then divide by 2, or you first add this, okay, get the value, and then that value you divide by 2. Okay, so whichever way is convenient for you, you have to do that. And the value here is 30.0, Okay, and here it will be 43.5 and 54.0. So as you can see, we have calculated the mean value of the length. Okay, so the two L values, we will take the average and enter in the this column. Okay, after that you have to calculate the root T by L value. Okay, so what is the root T value? Root T value is 2.2. Okay, and here you can see the unit used is meter, that is in SI unit, but here we have got in centimeter. So what you will do is you will divide by 100. So 30 divided by 100 will be 0.3. So 2.2 divided by 0.3. So the first reading for root T by L is 2.2 divided by 0.3, which is equal to 7.36. Okay, equal to 7.36. And then you same way you will do for all the readings, that is 7.19 and 7.09. So then you have to take the mean value, and then one more table you can add here for finding out the frequency. Okay, so eta is equal to 1 by 2L root T by root M. Okay, so that calculation also you can do here, and the unit used will be in hertz. Okay, so that is the same formula that we have used here, the same formula I have written. Okay, so what you will do here in this formula is, that is 1 by 2 into 1 by root M into root T by L, isn't it? So what is 1 by root M? So in our lab, okay, we are using 1 by 2M value, 1 by 2 root M value as, so this 1 by root M is given as 29.72. Okay, so that divided by 2 is going to give me 29.72 divided by 2 is going to be 14.86. Okay, so keep that value in mind. 14.86 is the value of 1 by 2 root M. Okay, so then that value and root T by L you will multiply and write here. Okay, so that will be 14.86 multiplied by 7.36. So that is going to be 109.4. Okay, similarly you will do for all of them. 14.86 multiplied by 7.19. So that is 106.8. And then last reading, 14.86 multiplied by 7.09. That will be 105.4. Okay, 105.4. Hope you can see that. So then you have to take the mean value of these three. Okay, so mean value of the frequency will be 109.4 plus 106.8. Don't forget to use the bracket. 105.4 divided by 3. Divided by 3. So the value is 107.2 hertz. Okay, don't forget to write hertz here. And after you have calculated 1, 2, 3 root T by L, when you have calculated the three readings. Okay, and then you have also calculated the eta value for the 3. Eta is equal to, that is the frequency. And then finally, this is the frequency of the sonometer. So the frequency of the AC mains will be the frequency of the sonometer divided by 2. So that will be 107.2 divided by 2. So that is equal to 53.6 hertz. Okay, so this is slightly higher than the original value, that is original value should be around 50 hertz. Okay, so but this is just a example calculation. So whatever reading you are going to do in your lab, depending on that you will write the values. Okay, so this is just an example of how you have to perform the calculation. Okay, so here you can see you can fill all the readings here, and then the frequency of the AC mains is 53.6 hertz. Okay, so everywhere you have to mention the unit, and finally the frequency of the AC mains by using sonometer is 53.6 hertz. Okay, so there is no graph for this one, so it's a very easy experiment once you know how to do the calculation. Clear? Okay, see to it that this particular column must be around 6.9 to 7. Okay, so the reading must not go beyond that. Okay, so if you're getting beyond that, it means you're doing something wrong. Okay, so usually it is around 6.9 to 7.